Good afternoon, all. Welcome to the course Analog Circuits. My name is Ganpat. I am the TA for this course. So we will start solving the assignment number one. So everybody can hear me?
Sir. Yes, sir.
Okay.
Yes, sir.
Yeah. We will wait for 5 more minutes, okay? So that other can also join. Okay, so we will start now. So let me share my screen. So everybody can see this assignment number 0.
Yes, sir.
Okay, fine. So we will start with question number 1. So the question is, if base current is 10 microampere, what will be the value of collector current in a common emitter amplifier if beta is equal to 50? Okay. So the given things are here. So here we have a BJT. So we have this collector terminal, base terminal, and emitter terminal. So the current through the base terminal is equal to 10 microampere. So IB is going uh, towards the base, and the value is 10 microampere. The IC will flow from the top to bottom, and the IE will be, just wait, and IE will be the addition of IC and the IB. Okay, so this IE is nothing but addition of IB plus addition of IC, that is I is equal to IB plus IC. Now beta is given and value of beta is 50. Okay, so the two things are given, one is IB is equal to 10 microampere and another is beta is equal to 50. Now we know that the formula of IC, that is a collector current, is equal to beta into IB. So can others also accept the like request? Yes, other participant can also accept the request, right? Yes, I'm asking you. Hello?
Sir.
Yeah, so you can also accept the request, right? If somebody wants to admit. Uh, because every time I have to again go back and again I have to accept. So is that possible with you, others like students?
No, sir.
No, sir.
Okay, okay, fine. Then I will minimize this somewhere side and then I will show you. Okay, fine. So yeah. So IC is nothing but beta into IB. Okay. Now we have the value of uh, beta, that is 50, and we have the value of IB, that is nothing but 10 microampere. So if you multiply 50 into 10 microampere, answer will be I is equal to 510 microampere. So the question asked is what is the value of IC? So value of IC is nothing but 500 microampere. So this is the answer. And if you want to calculate, let's say IE, then IE will be IC plus IB. So if you are putting IC plus IB, it will be 500 microampere plus 10 microampere. So IE you will get the value of 510 microampere. So the answer of the first question is 500 microampere. So is it clear? Yes. Any doubt about this question?
No, sir.
Okay, fine. So we will just see the proper option. So answer is nothing but 500 microampere, which is B. Okay, so you can take it here. Now we'll go to the question number 2. So yes, hopefully no doubt in question number 1. If anybody is having any doubt, just let me know. Okay, I will wait for 2 minutes.
So once again, repeat, sir. Just to be.
You want the solution?
Yes, sir.
Okay, so this is the solution. So here we have IB, IC, IE. Yeah. Okay, so hopefully there is no question, like no problem in question number 1. So I will go to the question number 2. Okay. So the question number 2 is which diode is used in the voltage regulation circuit? Okay, there are different options are given like Schottky diodes, pin diode, Zener diode, and tunnel. Okay, so the answer is Zener diode. I will just explain little bit about the Zener diode. Okay, so there are two terminals for the Zener diode. One is anode and another is cathode. Like any diode, it has a two terminal. The properties of Zener diode is when you are, so here it is forward bias. Okay, so Vz, uh, so the value of Vz is positive in this direction. Okay, and value of Vz is negative in this direction. Okay, so when it is positive, it get it suddenly start flowing, the current start flowing through the diode, and the characteristic will be something like this. Okay, so this is the current Iz through the Zener diode, and this is the voltage, that is Vz across the Zener diode. Okay, so when you are forward biasing, that is when your positive terminal have higher voltage than negative terminal. Okay, that time it will become a the diode become forward bias, and it will start, the current will suddenly increase through the Zener diode. Now when you are applying in opposite direction, so let's say instead of positive uh, instead of you apply the positive voltage as cathode, let's say here, and negative voltage at anode, in that case, diode is the reverse bias. And when it is reverse bias, what happens is it needs lot of voltage, okay, to for the conduction. That means initially there will be no current, and after some time there will be the Zener breakdown where there will be sudden increase in current. Actually, diode gets breakdown, and because of that, there will be suddenly increase in current. But at the same time, the voltage appear across diode will remain constant. That means the uh, it will produce the constant voltage, and this property we utilize for the producing the reference voltage. There is a constant reference voltage, and that's what the question is, that which diode is used in the voltage regulation circuit. So when you have a circuit and when your voltage reaches to Vz, okay, diode get reverse bias, and it can carry any amount of current, you can see here, but the voltage across diode remains same, and that's why we use in the voltage regulation for Zener diode in the voltage regulation to generate a constant voltage, but we have to apply the reverse bias voltage for that. So the answer of the question is Zener. Okay, so any doubt in this question? If you have any doubt, please let me know. I will wait for 2 minutes. Okay.
No, sir. No, sir.
Okay, fine. Then we will go to the question number 3. So the question number 3 is, which passive component can be used for blocking the DC path between two nodes in a circuit? Now, so the capacitor. So when when you have a capacitor, right? What we do is, the property of capacitor is it will pass only AC component and it will block the DC component. So why it is so? So if you see the impedance of the capacitance, it will be 1 by j omega c. Okay, j omega c. So if you put W, that is omega, that is a frequency, equal to 0, what will happen? In that case, this Z become infinity. Okay, that is, it act as a open circuit. So it actually, there will be no connection between AB. But when when you are increasing the frequency from 0 to infinity, what will happen? This 1 by j omega c start decreasing. Okay, and because of that, the impedance from A to B will start reducing, and when you reach omega is equal to infinity, what will happen? The value of Z will tends to 0. Okay, so that means the capacitor pass AC component and it blocks DC component. So that's why the answer of the question is capacitor. That is second answer. Which passive component can be used for blocking DC between two nodes in circuit, which is nothing but the capacitor. Okay. So any doubt in this question? Yes. Any doubt?
No,
Please
sir.
No,
let me
sir.
know. Okay, fine.
No doubts.
No, sir.
Okay, no
No
problem.
doubt.
Okay, so now we'll go to the question number 4. In which region of operation a BJT works as an amplifier? So there are three answers, like triodes, four answer: triode, saturation, cutoff, and active. Okay. So we will go back here. So this is the BJT symbol. So as I shown before, this is capacitor, this is base, and this is emitter. Now, when you plot the properties, that is a characteristic of the BJT, that is current through BJT IC versus VCE for different VBE, you will see this kind of characteristic. So initially, when there is zero VCE, okay, at this point, what will happen? The current is zero through the capacitor. There will be no current through the capacitor. That is when VCE is equal to 0. IC is nothing but, that is the current through the capacitor will be 0. Okay. Now, as you start increasing VCE, what will happen? Depends on VBE value between base and emitter. IB will start flowing through the base, and because IC is nothing but beta times IB, IC is nothing but beta times IB, IC will also start increasing. You can see here, okay, IC will start increasing here. Now the value of maximum current achieved by IC BJT, that is a collector current passed through the BJT, is depends on the value of VBE. Okay, so in this case VBE1 is more than VBE2. Okay, so this is greater than VBE2. Okay, VBE1 is greater than VBE2, and that's why the IB1 will be, the value of IB1 will be more than value of IB2, and which result in, because we know IC is nothing but beta into IB, the current because of IB1 will be more than current because of IB2. So now there are three region of operation for this BJT. Okay, the first is saturation region. The saturation region is a region where value of the VC value, that is voltage of VC, is lesser than VB. Sometimes people say it is 0.2 times less, 0.1, 0.3 times less. So, but in general, practically speaking, if your VC is at lower potential than VB, your transistor, NPN transistor, will go into the saturation region. And if you see here, this VCE, that is, there will be sudden increase in IC as compared to sudden increase in IC when there is any change in the VC. Okay, so the output impedance, that is change in VCE with respect to change in IC, will be very less. So output impedance in this region, that is when VCE is less than VB, will be very less. Okay, so let's say R saturation is equal to R1. Okay, now as you are increasing the value of VCE further, you will see there is not much increase in the IC. Okay, that means the output impedance in this region is higher compared to output impedance in the saturation region, which tells us that active impedance, the output impedance in active region is more. Now, what is the formula of the gain? Gain is nothing but GM, that is the transconductance of the BJT, into RCE, that is output impedance, in parallel with RL, that is a load impedance. So for time being, we can assume that RL is equal to infinite. So the effective equation of the gain is GM into RCE. Now from this graph, you can clearly see that RCE in the active region is much more than RCE in the saturation region. That's why the gain of the BJT is higher in the active region as compared to saturation region. So the answer is saturation, active region. Okay. So the region of operation for BJT to work as an amplifier is active region. Any doubt? Yes.
No, sir.
No, sir.
Okay. I will wait for 1 minute. If you have any doubt, please let me know. So I hope there is no doubt in question number 1, 2, 3, and 4. If you have any doubt, then please let me know. Okay. Now we will go to the question number 5. Which filter passes high frequency signal but blocks low frequency signal? Okay. So there are three types of filter. So low pass filter, second is band pass filter, and third is high pass filter. So the property of low pass filter is it will pass only low frequency component and it will block high frequency component. The property of the band pass filter is it will pass the signal between the some selected bandwidth. Okay, it will neither pass very low frequency nor very high frequency. It will have some selected bandwidth, like it will pass only the signal between the some selected bandwidth. That's why it can call we call it as a band pass filter. That is, it will pass specific band from the input to output. And the third type of filter is high pass filter. So high pass filter only pass high frequency component. It will not pass neither will it will pass low pass component or band pass. It will pass the high frequency component. So in frequency domain, if you want to see the like characteristic of these three filter, it will be like this. So for low pass filter, so here it is H, that is a transfer function of the filter, and on x axis omega, that is the frequency of the filter. So the transfer function with respect to frequency of the low pass filter will look like this. That is, at lower frequency, it will pass the input to the output, but as you are going to the higher frequency, it will block the higher frequency component. That is, the gain of the low pass filter at higher frequency will be less, and as you are going for very high frequency, it will be 0. Now the characteristic of band pass filter is like this. So H, that is a transfer function of the band pass filter with respect to omega. Okay. So it will look like this. So neither it will pass very low frequency component nor very high frequency component. It will pass only some selected frequency component. So here I am denoting those frequencies as omega 1 and omega 2. So other frequency it will not going to pass. Now third type of filters are the high pass filter. So high pass filter will pass only high frequency component. So here is a transfer function that is denoted by H, and x axis is denoted by omega. So the characteristics of high pass filter is like this. So as you are going for lower frequency, the transfer function value will be very less. That is, gain of the high pass filter is very less. But as you are going to higher frequency, it will approach to the 1. Okay. 1 or multiple of 1. Same thing is here. So the answer of the question is high pass filter. Okay. So the which filter passes high frequency signal but block low frequency signal? Answer is a high pass filter. Any doubt? Yes, any doubt?
No, sir. No,
Okay,
sir.
No, sir.
okay, fine. Now the next question is BJT and MOSFET work as. First is current control voltage source and voltage control current source. Second is current control current source and voltage control current source. And third is current control current source and voltage control voltage source. And fourth is none of the above. So we will see. Okay. So this is the symbol of BJT, and right hand side we have the symbol of MOSFET. Okay. So you know that collector current, that is IC, is beta times IB. Okay. So IC is beta time IB. So the IC will flow only if there is current through the base of the BJT. Okay. Now in case of MOSFET, the current through the MOSFET, which is ID, is equal to beta by 2 into VGS minus VT square. Okay. So I will write down here. So ID is equal to beta by 2 into VGS minus VT square. Okay. So, and IC is equal to beta into IB. Okay. That means the collector current is a function of current, function of base current, and the MOSFET current is a function of gate to source voltage. So we can say that BJT act as a current controlled current source. That is, when you are passing IB, depends on value of beta, the IC will change. That is, IC is equal to beta into IB. And in case of MOSFET, MOSFET act as a voltage control current source. That is, when I am changing VGS, depends on the value of VGS, current, that is current through the drain, that is ID, will also change. So because ID is a function of VGS, and in case of BJT, IC is a function of IB. So answer is BJT act as a current source, and MOSFET act as a voltage control current source. Is it clear? Yes. Any doubt?
No, sir.
Okay. So we will go to the next question, that is question 7. So how many poles and zeros are there in the first order passive high pass filter? Okay. So we will first see the transfer function of the high pass filter. So you can represent high pass filter as a C connected to the resistance, that is capacitor connected to the resistance, and Vi is applied to the capacitor, and output is generated across resistor. Okay. So this is my C, that is a capacitor, and this is my R. So if you see the transfer function of the VO by VI, okay, V naught by VI, that is a transfer function, it will have the form of AS divided by 1 plus BS. Now this A and B both are depends on the value of R and C. Okay. Now this, if you put S, so S is what? S is the frequency component. So if you put S is equal to 0, okay, then what will happen? The value of this transfer function is equal to 0. Okay. So when S is equal to 0, the value of transfer function becomes 0. That means we get 1 0 at S is equal to 0. So we will get 1 0 at S is equal to 0. Okay. Now, when you are putting S is equal to minus 1 by B, what will happen to the denominator? Denominator will become 0. And when your denominator is 0, what will happen to the transfer function? Transfer function value will be infinity. So, you will get one pole at S is equal to minus 1 by B. That means in this high pass filter, there is one zero and one pole. So there will be one zero and one pole. Okay. So the answer of the question is one pole and one zero. This is a C is the answer. So any doubt? Any doubt in this question? Yes. Any doubt?
No, sir.
Okay.
No, sir.
Fine.
No, sir.
So we will go to the next question. So the next question is, in case of non-inverting op-amp, what is the phase shift in degrees between input and output? Okay. So first we will see what is the non-inverting amplifier. Okay. So non-inverting amplifier means if I am giving input Vi, okay, and let's say if it has a polarity is equal to positive polarity, okay, then output will also have the same polarity. That is, VO will also have the positive polarity. Okay. Now, if Vi have a negative polarity, then what will happen to the V naught? V naught will also have the negative polarity. So, both the Vi and V naught have the same polarity. Okay. So graphically, you can see this. Okay. So let's say my Vi is like this. Okay. Sinusoidal. Then what will happen here? When I have a positive polarity, the output phase also will have the same angle. There will be no phase angle between the input and output. Okay. So if Vi is look like this, then V naught will be like this. And this amplitude of the V naught depends on the gain factor. Okay. So that means there is zero phase shift between the input and output. There is no phase shift. Okay. So whatever, so if let's say Vi have a phase of let's say 20 degree, then VO will have the same degree. If Vi is a 0, then VO also 0. So there will be no phase shifting between the Vi and VO. So the answer of this question is 0. Okay, that is a B. Any doubt? Yes. Any doubt?
No, sir.
No, sir. Fine. So now question number 9. Which transistor configuration is used for both voltage and current amplification? Okay. So we will see. So basically there are three types of configuration. One is common base. Okay. That is we call as a CB configuration. Okay. Then common collector, that is collector is common, and third is a common emitter. Okay. Now just I will draw symbol of BJT first. So in case of, so here I have a collector, here I have a base, and this is emitter. Okay. So when I'm using common base configuration, at that time, base will be having some DC voltage. Okay. We apply DC voltage to the base, and there will be transition of signal from emitter to collector. Okay. When we have a common collector, then we apply DC voltage to the collector, and there will be transmission of signal from base to emitter. And when we have a common emitter configuration, that time the emitter will be connected to the ground, and there will be transmission of signal from base to collector. Okay. Now we will see one by one. Okay. So let's say first time I consider the common base configuration. Okay. So in, as I told you, in common base configuration, this base will be at some DC voltage, and there will be signal transmission from emitter to collector. Okay. So when signal is transmitting from emitter to collector, what will happen? What is the relation of current, that is IE and IC? So IE is nothing but is equal to beta divided by 1 plus beta into, just wait.